So, welcome back to part 2 about talking about L'Hopital's rule. So, just as a review, for L'Hopital's rule, you need so it's about a limit. And if you have some sort of fraction with the indeterminate forms, either 0 over 0 or infinity over infinity, then you get that the limit as x goes to a of f of x over g of x is the limit as x goes to a over the ratio of their derivatives. An example of one that is of the same type that we ended yesterday with is, well, let's look at what the limit as x goes to infinity of x cubed e to the negative x squared. So, as x goes to infinity, x cubed goes to infinity, e to the negative x squared goes to 0, because you have a negative exponent, and the variable is in the exponent. Now, one way of thinking about L'Hopital's rule is whether it's going to tend towards something that's closer to infinity or close to 0 is really dependent on which term dominates. Does x cubed dominate, or does e to the negative x squared dominate? So we're going to have to think through how to do this one. So if I have this thing, it's not quite in the form for L'Hopital yet, but remember, negative exponents means that I can use algebra to change this to 1 over e to the x squared, which is the limit as x goes to infinity of x cubed over e to the x squared, which that one is infinity over infinity. So by L'Hopital's rule, we take the derivative. Top is just basic power rule. The bottom, you need chain rule. It's e to the x squared times 2x by L'Hopital. Clean that up a little bit. Because there's no addition, we can cancel stuff out. You get 3x over 2 e to the x squared, which is still an infinity over infinity. So we're not done. We can do L'Hopital's rule again to get derivative of the top is 3, derivative of the bottom is 2 e to the x squared times 2x. And that's by L'Hopital, which the top is just a number, just 3. The bottom, you have these two things. This is going to infinity, this is going to infinity. Together, multiply, they'll go to infinity. So 3 over infinity gives you 0. Okay, so that was just our quick review of yesterday. So let's go on to doing the next type that we're going to be looking at, which is of the form infinity minus infinity. So the method that you want to think about here is it's going to be ones where you're going to want to find a common denominator. By that I mean examples like, oh, my thing is having problems. Examples like limit as x goes to 1 of x over x minus 1 minus 1 over natural log of x. Right, if you plug in 1, you get 1 over 0, which is infinity, minus 1 over natural log of 1 is 0, so that's infinity again. Now we can't use L'Hopital's rule as is, but if we combine, we find a common denominator, this will be x natural log of x over x minus 1 natural log of x minus x minus 1 over x minus 1 natural log of x. We can combine those since they have common denominators. That will be x natural log of x minus x plus 1 by distributing this negative all over x minus 1 natural log of x. And if you plug this in, you're going to get, this term's going to be 0, this term will be negative 1, and 1 gives us a 0 over, this is going to be 0 times 0 gives us 0. So hey, we can use L'Hopital's rule now. So the numerator, you have to use product rule on x natural log of x, so that's going to be 1 times natural log of x plus x times 1 over x, and then minus 1. Because the derivative of negative x is 1, is negative 1, and the derivative of plus 1 is 0. Over the bottom, which is going to be, well, you have the natural log of x, because the derivative of x minus 1 is 1, plus x minus 1 times 1 over x. And this is, what is this going to give you? This is going to give you 0 plus 1 minus 1 over, the bottom is going to give you 0 plus 0. So again, we get 0 over 0. So let's apply L'Hopital's rule again. So the derivative of the numerator, you get 1 over x plus, well, if you simplify this, this is just 1. So it's plus 0 minus 0 over, derivative of the denominator is 1 over x. And then if you distribute this part out, you get x times 1 over x is 1 minus 1 over x. So that's going to be plus 0 and then minus a negative 1 over x squared. And if you plug in 1 now, you're going to get 1 over, that's going to be 1 plus 1 or 1/2. So, by applying this twice, L'Hopital's rule twice, what do we get? We get that the limit as x goes to 1 of x over x minus 1 minus 1 over natural log of x is 1/2. And that's just one example of a infinity minus infinity case. The main takeaway is that this whole find the common denominator. Because in these cases, typically, there'll be stuff that is some sort of fraction. And there will be some way of combining them. Okay, so the other type that we have is ones of this form. Either you have 0 to the 0 power, which the reason that's an indeterminate form is usually anything to the 0 power is 1. But the problem with that is there's a problem with 0 to the 0 power, mainly because you would be confused, is this going to be 1 or is this going to be 0? You have infinity to the 0 power. Again, is that infinity? Is that 1? We don't know. 1 to the infinity power. Is that 1? Is that infinity? The way we're going to deal with these is we're going to take the limit and say that it's y equals whatever the stuff is. And then we're going to do our old friend of taking the natural log and treat it as a product. So let's start with an example. Let's look at the limit as x goes to 0 from the right of x square root of x. If you do plug in 0, you're going to get 0 to the 0 power, which means this is an indeterminate form. So we say y equals x square root of x. And then we take natural log of both sides. Okay. We can use log powers or log rules with the powers to pull this out front. And then we could rearrange this. Right, this is going to be, we're going to say natural log of x over 1 over x to the 1/2. Similar, it's just a product. So then, and that's equal to the natural log of y. So now we can take this limit. So let me write it up here. Natural log of y equals natural log of x over 1 over x to the 1/2. So then the limit as x goes to 0 from the right of natural log of y equals the limit as x goes to 0 from the right, natural log of x over 1 over x to the 1/2. you look at a graph, and this is, so as x goes to 0 from the right of natural log of x, that's going to be a negative infinity over x going to 0 from the right of that is going to be infinity. That is an indeterminate form. So by L'Hopital's rule, take the derivative. You get 1 over x over, this will be negative 1/2 x to the 3/2, using that this is x to the negative 1/2 power. Okay, so let's do some algebra on that, and that was by L'Hopital. If we do some algebra, you have these fractions. I'm going to rewrite these as 1 over x times negative 2x to the 3/2 over 1. And using just rules of exponents, that will be negative 2x to the 1/2, which is 0. So these ones are a little bit more involved than some of the other ones with taking an natural log, but we're not quite done yet. We have that that's what the natural log of y is. So going back, we could say that the limit as x goes to 0, right, of x square root of x is the limit as x goes to 0 from the right of y, which using exponential rules is of e natural log of y. And then remember, if you have a continuous function, limits pull through, and the exponential is a continuous function, so this is e limit x goes to 0 of natural log of y, or e to the 0, which is 1. So yes, these are a little bit more involved. And so these ones I will not give you as many on, say, a quiz versus the other types that are like the quotients and the multiplication ones. Okay, so that's all I have for this section. Again, if you have any comments or questions or concerns, comment on this video or send me a Canvas message. And I will see you all tomorrow.